Morning, Sachin. Morning, sir. Are you there? Morning, sir. Are you there?
Hello, sir. Good morning, sir. Yes, sir. Can you hear me, sir?
Hey, good morning. Yes, sir, you're audible.
Okay, sir. Rahman, sir. Hello.
Hello?
Sir Rahman, sir. Uday Shankar, sir.
Yeah, Uday here.
Okay, sir. Whether the media was presented?
I'm sorry, my idea was?
No. Whether they have made you as presenter?
It says guest, so, but I'm able to get the option to present. I think I can share. That shouldn't be a problem.
You can share, sir. You can share, sir. You are already a presenter.
I'll just give it a try.
Try to share, sir.
Yes, sir. Yes, sir.
Sir,
Is the screen visible?
Yeah, yes, sir.
Perfect.
It is visible.
Right. No worries. Thank you.
Okay, sir. 1 minute, sir. We'll check it and we will start.
Right.
Sir Rahman, sir.
yes, sir. Please introduce our guest to the audience.
So, good morning, everyone. I welcome you all for the fourth day of our FDP. So today, Mr. Uday Shankar is going to take care of this session. So I am very happy to introduce about Mr. Uday Shankar. So first of all, did you know that Uday is the only Indian recipient of the Young Achiever Award 2020 from Mother Teresa University, Australia. So I am very happy to give this information. So then I would like to brief about Mr. Uday Shankar. So he has done his BE instrumentation from PhD Coimbatore and specialized in robotics from the University of South Australia. So there are pursued engineering design from the University of Hull. So during his college days, he has won 14 lakhs rupees prizes, and also he holds his studied numerous national awards, some being from National Instruments, Texas Instruments, Harrison, Accenture, and also from Yahoo. So during his tenure abroad, he had completed 3 projects and received a letter of appreciation for the same. So Mr. Uday has been featured multiple times in print and mass media. His passion for teaching and skill of innovation lead him on the path to make children future ready. He founded Do It Yourself Academy. So it is a very nice name, Mr. Uday. So I appreciated the name.
Thank you,
So
sir.
a maverick aimed at offering comprehensive lab experience to learn, understand, and implement concepts for students to develop expertise in robotics. And also 3D printing, industrial automation, artificial intelligence, and mainly Internet of Things. So this academy, DIA Women Entrepreneurship Initiative, has been awarded the most promising business for women. DIA has received Best Futuristic Education Company Awards and Excellence in Robotics Education Award. Mr. Uday is an engineer by profession, educated by art, and an entrepreneur driven by passion. His ambition is to build a global education enterprise focused on making students future ready. Mr. Uday will be sharing practical applications of IoT and helping us with a live demo as to how IoT and artificial intelligence can save a life. So thank you for this opportunity. So now I welcome Mr. Uday Shankar and take over this session. Please, sir.
Sure. Thank you so much, sir. So before we go ahead into what is IoT, so from our audience here, I'd like to understand what all have you done in IoT? So where do you think IoT can help you or your students? And moreover, why do you need IoT? So if your audience, if the participants can please share in chat, so I'll be able to read your responses and also come back to you with what exactly we're doing this for and what should be the outcome. So we have more than about 70 participants today. So if any of you could please share where and why do you think IoT can be applied by your students to help them in their career going ahead? So I understand most of us here are educators from the college side. Home appliance is perfect. So we are in the position we are going to be guiding students to build their projects. So definitely I'd be happy if I get some inputs from your end as to where you think we can apply. Power grid, medical, home appliances. So make everything available on the internet. Very nice. And do whatever action you want remotely. Very nice. So you have about 4 simple applications. Now, let's take the first one for instance. So when it comes to home appliance itself, now today we are coming and looking at a point where you can say right from your bed coffee to getting your heaters on, might even be a point when robots brush your teeth. So a complete sequence right from your wake up music, curtains opening up, sunlight falling on your face, pleasant music playing when you wake up, and once you go into the bathroom, lights switch on automatically, and all that step by step you can do it. Making your coffee, so all that will just come to you. In terms of power grid, you can automate as to how much of power consumption is being made at each grid, at each unit, what is the power consumed, which is the device that is taking up maximum amount of power. So all those things we can easily control. And next, make everything on the internet now is the case, right? So through internet, you're able to control everything. So right from your factory to your house, anything can be controlled over the internet. And next, from a remote location, you can even control robots. Say, for example, drones and robots being used in the LOC and in your borders can be controlled from anywhere. And in terms of industries, we have automatic control systems where you just tell the factory that, hey, I want so much today. And the factory can do something like just in time and get you the products you need. And finally, in terms of robotics, the robot will follow exactly what commands you give. And you can get to see all the data from the robot anywhere from a remote location. You can take whatever decisions you want based on the sensor data you get from the robot. So such is the application of IoT. So the limit is our imagination. If you see where it is being used in terms of robotics, AI, IoT, 3D printing. So right from the food we eat, the dress we wear, the cars we travel in, our house construction, and even the doctors are today going to become robots. And all these robots are being powered by smart sensors and transducers. They can have high precision output in terms of movement to the level of microns also in some cases. And even let's take air, water, land, or even space. Anywhere and everywhere, robots are being present. And they're, day by day, they're making our world safer, simpler, and secure, and make sure it is all the more faster in terms of speed, in terms of getting things done. So such is the power of the tools which are being empowered with. So we're going towards a world where man and robot have to coexist. So when this happens, it is very important and imperative for all of us to be prepared with the curriculum of the future, to be ready with the tools which can help us build a world of the future. So one simple thing, just for sake of sharing, since a lot of us here are working with children directly, is all about inspiration. So these are a group of 6 girls. They're all from BSc background. So they only know a little bit of coding, computer science. They have absolutely no idea in electronics. But within a span of 6 months, these girls, with a little bit of guidance from us, They built their own 6 feet robot powered by AI, IoT, and robotics. So this particular robot is now being used in their college as a receptionist. So which means right from the time somebody would walk in, so welcoming them, telling them which place to go to, where they can find all their, say for example, they want to meet the principal, it'll give them directions. They want to come for admissions, it will handle all the inquiries. They want to call somebody, it can connect them over a call. And in terms of security, the robot can go for rounds and report any abnormal sightings back to the head office or to whoever is responsible. So this was launched in a mega function. Now, coming back to our topic, a very important thing. So what is this things? IoT is nothing but Internet of Things, right? So when I say things, what are these? Now, for example, we're saying that things that see, that listen, and that talk. Now, can you give me some examples of this? What are these that see, listen, and talk? So what does it mean to you? So things that see, listen, and talk, what does it mean to you? So we have two things when it comes to IoT. One is the internet and two is the things, right? So in terms of things, so like their endpoints, what do you think they can be? Now I said things that see, that listen, and that speak. So what can these things be? So you can please use the chat box. Yeah, microphone. Thank you, Ravi sir. Anything else? Sensors. Wonderful. What else? A video. Okay. Alexa. Nice. An assistant. Any logical information. Okay. Now, what we get from the things are logical information for us. But what are these things? So the output of using the things is going to be logical information. Now, what is it we're going to get from the things, or what are these things? Now, for example, if I say things that see, listen, and speak, right? So first, in terms of seeing, what is going to happen is you're going to see all the parameters around us. Say, for example, how bright is the room? So we have a light sensor that can measure the luminescence in the room and give us a value, right? Things that listen, like somebody has lightly shared, for example, a clap switch or a microphone, so through which we can listen and process that audio through our platform. And in terms of talk, so talking doesn't have to be only verbally, can even be in terms of action. Say, for example, I can act by saying, if the light is low, switch on the tube light, right? So here I'm seeing with my sensor and my action is being performed through my output device, which is a relay to control the tube light. In terms of listening, let's say the microphones or let's say even some abnormalities, anomalies, and even the videos are being processed on the cloud to pick out what all we see as a difference from the regular. Now, to understand the world of Internet of Things, we look at a small experiment around the house, right? So now, let's take for example, in our presence are two glasses and there is water, there are two eggs, and there is coffee and there is bread. So with all these things in mind, think of an home automation or an IoT solution which a user can make use of, considering that he has all these objects with him. So what is it the user can think of as a technology solution? So what is it you think can happen? So let's make it quite interactive because I'm sure that just one-way communication might not be helpful for all of us. Prepare omelette. Thank you, Koteshwara Garu. So bring coffee to the bread. Eat bread, take coffee. Okay. Right. So now basically looking at a solution. Now end of the day, definitely we will look at having the bread, omelette and have a coffee. But what is it in terms of a solution which we can look at? Now where do you see automation coming in at this point? For example, now in terms of the coffee and the bread and the eggs. Now there is something called Amazon dot which was there. So in this what happens was, so every time you're running out of one particular object or item, you can automatically order if your account is being linked. Which means if I press the button once, I will get one packet of bread ordered in Amazon. If I press it twice, I'll get 1 kg of coffee added to my cart and automatically my account gets debited and coffee will come to my house. And third, in terms of eggs, so I can have a tray which is filled with sensors. So as and when I see that only 2 eggs, I've taken these 2 eggs for my omelette. So tomorrow I won't have eggs to eat. So as soon as the tray is empty, when the eggs are empty, the sensor will automatically notify my server, and my server will message to my Kirana store or whomever I'm talking to saying that so and so flat number, I want 6 eggs to be delivered. So automatically this guy can deliver eggs to your house just using sensors. And what about 2 glasses of water? And simple. So you just fill it and keep it there. Robots can carry that around for you. You can just say, bring me water. Just leave the glasses on the robot. The robot can carry that and come to you. Now saying all that reminds me of water. So in everything we see, though it might look very simple, there's always a solution that is waiting to be found, something which we can do very easily that will make a big difference. For example, if a dot button is being given to every house, so by default, he has acquired all the customers. So every time somebody needs a product, they'll just press the button and the order has to come to their place. So if you see how things have evolved over time, first and foremost, we had fixed phones, SMS and all that, where we sent a message when we want to talk to a person. And then we got the emails. And then we had the basic internet stuff like basic e-commerce sites and all that. And then we have social media. So now we are at a point where, let's say you want something searched on the internet, Facebook will start selling to you. So if you search something on Google, you'll find the ad in Facebook. So that is the kind of evolution has happened in terms of social media. And finally, machine to machine communication. So which means in this particular case, let's say you tell Alexa that I want water. Alexa can control the robot in your house and bring water to you. So in this, what has actually happened is your home assistant has spoken to your robot, and then your robot has brought water for you. So friends, I request you to kindly mute yourself if you're not wanting to talk. If you have any question, you can please leave a message and I'll ask for your name, and then you can ask your questions. Else, you can keep yourself on mute. Thank you.
So please mute yourself so that session will not be disturbed. So all of you, please check your mic and video.
Thank you, sir. So when you see in terms of evolution of IoT, so though IoT is something that has picked up the steam now, it's very famous. Everybody is talking about IoT, but quite honestly, IoT has been around for a while now. So so if you see, even the projects which even my professors have built just almost say about 10, 15 years back, they did use Internet of Things in a subtle way because we had embedded systems that was connected over GPRS, GSM and all that. Yes, the data was not fast, data was not bulky, more information could not be sent, but whatever basic information, we did do something at some level of IoT as well. Today, what has happened with Internet being the focus, Internet is the prime now, and now internet is supported by embedded systems. Before we had embedded systems supported by internet, but now it is internet supported by embedded systems. That is how the life has transformed over the years. So from a basic module where we had calculators and even your sensors and your medical devices, which could send information over the internet, give the important signals to the doctor and all that. But today we are at the point where even robots are performing surgeries over the internet. A simple use case was something which we had built for a company in IIT Madras. So we had the backend team. So we did something small for them. So we built a laser-based guidance system. So which means a doctor sitting in UK could just move his hands like this, and a laser precision system will calculate to the level in which his finger has moved, and the same way, to the same extent, that particular tool held by the doctor, the robot will move in Chennai. So the complete haptic system was developed by us, and it was completely delivered over the internet. So doctors just wearing a glove and performing like that, looking the headset, and he'll see what the robot is saying, and step by step he's performing the surgery. So that is the way things have evolved over time. And then we have your own personal assistants. You have your Fitbits, your Alexas, and you have your Google Homes and all that. And apart from this, what has also happened is we have now hardware with huge capabilities and inbuilt services to deliver what we expect in terms of an IoT product. Now, what is being said is more than 50 billion devices are going to be connected. So, if you see where IoT is being applied in daily life, in where we are today, first and foremost in terms of healthcare. So, in many cases, I've seen internet doctors, like, for example, a remote patient in a village can connect with a doctor anywhere in the world. Even in case of gynec, to measure the baby parameters, there's a small portable kit which can be used by anybody, just plugged in, and the gynecologist can just check the parameters from the hospital itself. So all this has been done through IoT, and the example that I just gave, and then smart apparatus, say for example, even a ventilator which you just developed, been given for approval, is being built using IoT. So the ventilator spec, the patient vitals, and all that, we give it to the doctor in a mobile app. So all these are simple things which IoT can do, make things global. And second, when it comes to automotive and manufacturing, so today at just a command, you can say that you want so many cars manufactured. So as soon as you send a message to a manufacturing factory, what happens is your production unit will start running. And then your line, the assembly line, the robots will start working. And once the level of say 25 cars is reached, they stop. So it is called as Industry 4.0. And through IoT, that can be enabled, and you can control a complete manufacturing process the click of a button. In terms of retail, we ourselves are the best examples. There are so many things in which just a click of a button and you get delivered. And even the stores, they're automating their stock. For example, let's say I have one rack full of one category of clothes. So my sensor can keep checking every time a dress is being removed from the rack. So Nigel said that when the dress reaches 3, it has to be refilled. So automatically the sensor will check when the level has gone down. He'll intimate my store manager and automatically places the order. Once the order is arrived, the intimation of store manager is made that order has arrived, and then the shop floor person can just pick it up and put it on the shelf, and then we are back to stock. So instead of this, what should have actually happened was somebody should go on, keep on checking what is the stock, which is low, make a list, give it to the boss, he will place an order over mail or send a purchase order. That person they will receive, he will receive the PO, send an invoice, and then all the entire process of packing, shipping will happen. But here, with just not even a click of a button, just mounting a sensor, the complete process is automated and will come, the product will come and sit in front of your door. So that is the amount of automation you can achieve through IoT. When it comes to education, similarly, attendance tracking, student health, where student safety, where they in terms of when traveling in a bus, and in terms of even their assignments, any kit rented out to them. So all this can be made through IoT itself. And finally, making our homes and our cities smart. So from a simple home automation to make your daily life easy, to controlling the traffics, controlling the pollutions, your signal timings, your parking control, everything. So IoT can change the way we live, make it all the more futuristic, simple, and reduce our time, money, and effort, and help us to take informed decisions in everything we do. So that is the power of IoT. So until this point, if you have any doubts, you can please ask me. I will answer the same in the chat. If you have any doubts until this point, You can please use the chat box and ask me your questions. Any questions? Okay, if nothing, can we proceed? Right. So IoT, Internet of Things versus embedded networking. Now, for example, IoT would definitely require an internet or LAN or WAN like that. In case of embedded networking, it can be easily done with something like in Zigbee also. So IoT is also a network, right? But in terms of here, the reach would be global. In case of an embedded system, the network can be anything. It can be RF, it can be even Z wave. So in a refined RF as a Zigbee. So all this can happen. But Internet of Things is very, very specific. So primarily being number one, the protocols that are being followed in terms of IoT, and second, in terms of the devices that come in handy, which are ready-made, which can be used by the user, and third, the protocol which may be Wi-Fi, but in case of others, it might vary. So though it is also a network, though it is also embedded systems, so I can easily say that IoT can be a subset of embedded networking with more emphasis on having a global outlook and better reach, faster processing, and signaling protocols would be different. Great. So we'll just proceed. You see, in terms of trends, it is in early 2000s where people started conceptualizing, and when IoT as a concept to the market it came was almost 2009, and it has been growing consistently over the years. But right now we're at a point where everything is becoming smart, right from our sockets. Say for example, I'm connecting my TV to a socket. I can just switch on, switch off TV. I can even change my channels with IoT. I can, let's say I'm outside, I'm in a holiday, and some guest is coming to my house. I can just say go to my door, and I can just open the door of my house from wherever I am in the world. They can go in, and temporarily can give them access to control all the lights and the fans in my house to their mobile app. And once they leave, I can remove it. So like that, everything is being simplified. Everything is being made easy through IoT. So, and it's come to a point where it is huge adoption, and we're saying that there'll be almost 50 billion devices. So imagine the amount of work and the opportunity which IoT can offer to us. Now, like I said, embedded systems and basic internet has been on for a very, very long time. But why are we talking about IoT now? What has changed? First and foremost is the hardware cost has become much, much cheaper. Now, say for example, there was one point of time where you wanted a basic computer can just do even your dot codes. You had to need an entire room. Now, in the palm of your hand, you can launch a satellite. That is the amount in which the hardware has become more sophisticated, it has become more powerful, and has become much, much cheaper. And second is the tools. So before the softwares, the open source tools, the support system, the platforms are not that much. But today, development is much, much easier because of the communities. A lot of companies have launched softwares to make it easier, portals, and we live in an era of data. Internet has become cheap, bioavailable, and has given us more and more data and bandwidth to send across stuff. So now in terms of IoT, there are four basic blocks. The first and foremost is your devices and your endpoints. In terms of your devices, I would say your central hub, maybe your Alexa, maybe your router and all that. In terms of endpoints, you have your switches, you have your relays, you have your sensors and all this. So all your what you listen, what you hear, and what you speak, what you see, and all this are going to come as your endpoints. In terms of devices, we also do smart devices. In terms of device management, we're going to decide how to collect the information, where to store, and how to process the information, and what decision you can take from those. So next part would be filtering. Now, I'll be getting lot of information saying that door open, door close, door open, door close, door open, door close. Now, I can say that if my door is opened and closed after 11 p.m. and before 6 a.m., give me a notification. So here you choose precision in terms of what timing. An event is if my door is opened at this particular time, and notification is that what should they do. So I should get alerted, I should get a buzzer, I should get an alarm saying that somebody has opened my door in this time. And finally, the user management, I can say what are the permissions. Now, if I'm in my house, let's say there's a husband, there's a wife, and there are two children. So husband and wife can be the admins, and the children can just be users. So they don't have much control like when to open the door, when to close the door, security on, security off, and all those controls have not to be given to the children. So like this, there can be a strong and secure user management through IoT. So when a product or a project strategy is being made, these are the stuff which we have to decide first as a strategy, as a plan. So after this phase, you come to something which we call as the web of things. So Internet of Things is your complete physical objects in internet, which is actually what you can see and feel. But web of things are your supporting layers and protocols that the styles of the frameworks which users use and companies use to make sure that communication is happening between all the devices and able to come and make a decision and even store data. So if you see a simple example of a hobby project, now here Raspberry Pi is going to be my central server, and then I have sensors and I have actuators. In terms of actuators, here I put LED1 and LED2. This can be a tube light, this can be a fan, this can be a buzzer, anything. So whatever output device you want, you can feature that over here. In terms of the inputs, you have your PIR sensor, which is your input sensor, and then you have your temperature sensor, which can give you the temperature as to how hot the room is. And the PIR will let you know if somebody is crossing the way or nobody is crossing, if some presence is being felt or not. So the beauty about PIR is it's a plastic infrared. So only if it feels some heat, a hot body, it will sense as proximity. For example, let's just say you put a book in front of a PIR, it might not sense. It needs a warm body, maybe a cat, a person, a dog, a monkey. It can sense anything with a warm body. And finally, humidity sensors to see how moist it is. Say, for example, you want to water your garden, water your plants, and just put these sensors in the soil and you can get notifications. A simple use case would be, for example, if I take a PIR sensor as a use case, if somebody opens the door and enters when I'm in alarm mode, so in that case, the notification goes to your Raspberry Pi, and from then to your actuator, it will be the buzzer, and say it will make a huge noise alerting all the neighbors, and can even send SMS or WhatsApp or mails to the station and those who need to be notified. And second case, in terms of temperature, let's say you put this in your bedroom, so automatically Raspberry Pi can control and switch on your ACs, set the temperature, and make sure by the time you come home, the room is very, very comfortable and you can enjoy your stay at home. In terms of humidity sensors, let's say going on a trip for 1 month, if you don't water your plants or feed your fish, what will happen? They'll die. So in an aquarium also, you can just mount hardware device which can open and close the fish food. You can measure the humidity, let's say in your garden. So as and when your humidity level comes down in the soil, humidity and moisture level comes down in the soil. So once the moisture is low, immediately the watering system is switched on and water is sent to your plants. In terms of humidity, maybe controlling your fans, your ACs and all that again. And also in this, you can monitor data as to when it has been switched on, when it has been off. So when you come back, you can get a detailed report as to what has happened around you. So the possibilities with this are infinite. So there are some really big players in the industry. So I'll be happy to share this with Mr. Sukumar. So he can share this with you. So some big players in the industry have made some excellent applications of IoT. So I'll just show you one small DIY tool later on. So for now, let's proceed. So this is a very important part when it comes to the structure of a complete Internet of Things. The first and foremost will come your networked things. Now, what are your end effectors? What are the ones that is giving your input signal? And what is it through which it is being conveyed? So what is the protocol? Say, is it Wi-Fi, is it Zigbee, is it Bluetooth, is it NFC? So what is it that is being used to send across the data? And second, what are the objects that have been controlled? So your controllers, even your cars, your lights, your smart devices, your beacons, and all that. Second layer is the access. So now, how do you control them or send them? What protocol are we going to use? For example, HTML is one protocol, MQTT. All these are protocols which we use to ensure data delivery is being sent. And next is in terms of finding. Now, here we need to find where this particular object is linked through the internet. And third, in terms of social media and all these networks, in terms of authentication, encryption, and web of things, will come your share area. For example, let's just say you can on your social media itself, you can start sending messages. For example, I can connect a number to Telegram. I can just send a message to Telegram saying that switch on the light at home, and automatically once I do that, through a lot of things like Dialogflow, a tool by Google for AI, so basic AI and NLP actually. So here what happens is, as soon as you send the message to Telegram, the light in your house is being turned on just by sharing on social media. And finally, your compose layer, which has things like IFTTT. IFTTT is nothing but if this, then that. For example, if light is low, then switch on the light. So if light low, then what to do? Switch on the light. This is how things you can think of to build a complete end-to-end solution along with architecture for your product. All right. So at this point, I'll just give you like 5 minutes. You can just ask me the questions. You can just run through and just think of what comes to your mind. So I'll look for your questions or any doubts you have in the chat box. So is the pace okay? Am I going too fast?
Please ask if you have any doubts.
Am I going too fast? Is it okay? Easy to understand? I mean, keeping it simple, like please tell me if I'm going too fast. I can adjust my pace accordingly. So HTTP is like hypertext transfer protocol. So here an MQTT is specifically in terms of what protocol. So basically what happens in MQTT is the speed of transfer, and for example, we say that acknowledgement is something we use in network analysis. Say for example, if you send a message, is the host or the sender and receiver. So when a message is being sent from sender to receiver and here to here, now let's say for example, every time you send a message to here and he is acknowledging. So what happens? Data is coming, going and coming. So now the time taken will be higher. Now let's just say this guy is just sending. And outcome, we will wait when the user has to see. So MQTT is more fast with lesser data packet loss, information communicated in a very small chunk, and ensuring that what you request is being delivered. So optical fiber definitely, so of course it can be. So let's just say your central hub is connected to your say Raspberry Pi as such. So in that case, what happens is your data being transferred from your hub to the main can be faster. Or let's say you want to upload videos. Now let's say connect your Raspberry Pi at home and you connect Raspberry Pi cam or any camera to the module, and you want this video to be streamed to let's say a web server or let's say to your phone or anywhere. So in that case, if you use an optical fiber, the data transfer is going to be much higher. That can be done pretty much. Next, how can you give a simple example so we can understand all layers easily? I'll do that. Next, so Harjit Singh. Mr. Harjit Singh has asked, how would it be helpful for the designer? Now, normally what happens is, when we design, then sometimes we tend to miss out on small things. So what happens is, only when you do the architecture and try to implement something, you think, oh my God, I should have done that at this point of time, and now I've missed it, I don't know what to do. So they get stuck midway, and what happens is, when you miss something, you might have to go back, and you will be having to do a major part of code again. So when this happens, it's a huge waste of time. So we can avoid all this by ensuring that from the starting it is done in terms of what hardware we use, protocols, and all the 5 parameters which have been mentioned. In that case, the strategy, the plan, the structure will be right from the start, and we can easily proceed in the direction we want to complete a project. So now coming back to Mr. Avinash. I'll just share a simple example of how this can be used. So first is the networked things. Next we have the access, and then we have the find where the device is, and next we have the share, and next we have the compose. Okay. Now, for example, let me take Telegram as a social network over here, and then over here, let me take, for example, web things model or something as such, and let me take over here MQTT. Let me take over here my sensor and my controllers, and over here is my protocol. Now let's look at an example of a smart farm. So in a smart farm, let's just say you want to control the watering, and then let's say you want to control the moisture sensors, and then let's say you want to see what is the motor running or not, and then you want to control what is the produce. Let's say you want to measure the soil nutrients and all these sort of things. So there in network things, you will have your controller or your processor, and then you have all your sensors connected to this. And then next step comes your MQTT. So this is a protocol in which your controller will communicate through the nearest hub as a protocol of communication or sending the data. Since it is over the internet, there has to be some protocol that is being followed. Either HTTP or MQTT is the ones which we follow. So MQTT is my preferred choice. So here what happens in MQTT, let's say I have about 50 devices, and there is say a Raspberry Pi, there is a ESP, there is my sensor. ESP is my Wi-Fi powered microcontroller. So now ESP to Raspberry Pi, I can send data through MQTT, and this Raspberry Pi can be connected, let's say, through fiber, again to internet or whatever. And now using my search algorithm or find, so I need to find where is my ESP. For example, let's just say I have sent switch on motor in the land number 2 or switch on the second motor. I've given a command. So I need to find where is that second motor and send information to that motor to switch on. So that particular route will come in my find layer. And then comes my share layer. So once motor has been on, I can send a message saying that motor has been switched on, and also I can get notification saying that the moisture level is now normal in across all the farms. And that message can come to my Telegram. And finally in IFTT, let's say I'm not sending any message. Alright. So the farm is running on autopilot mode. So the moisture level has come down in the soil. So immediately what will happen if the moisture level has come down in the soil, what to do? Next, I'll get a message on Telegram saying that, hey, the water level in your moisture or the moisture level in your soil in your farm is low. Okay, and immediately what it'll also do is it'll look for the motors, and then it'll send communication in the MQTT protocol saying that to that particular motor, switch it on through the ESP device. So now without me having anything to do, the complete product has decided through IFTTT saying that the watering has to be done. Second, it has intimated me through the social network of Telegram saying that your motor has to be switched on, and because your moisture is low. And third, it has found where is that motor. Fourth, it has sent an instruction to that particular controller to which the motor is connected through MQTT. And fifth, the motor has been switched on and the water is going to the farm and my plants are being watered. I hope that is clear. Is that clear? Perfect. So I'm happy to introduce Mr. Miro, my mentor, my guide. So Mr. Miroslav Kotsaki has joined us from Australia, electronics. He's an expert in IoT. He has more than 30 years of experience in developing embedded systems. He is the founder of the software which we know as Easy System and RunLink. So he's the one who has created a complete AI platform. It is even being used by the Royal Allied Air Force. He's a mentor to students across the world. He's taken students to competitions in Malaysia where his students have won the International Innovation Contest. And one of the students, Max, he has built an IoT device in less than 3 hours, and SAP has taken him and they now works for SAP with that. So he is an embedded engineer. He has built IoT protocols. He has built IoT platforms. He comes with an amazing experience of building wonderful tools. Thank you so much, Miro. Thanks for joining us.
Thank you. It's good to join you as well. Can everyone hear me clearly?
Yes, sir.
So Miro, before we show the participants the platform, can you please give them a brief as to what RunLink can do, what it is?
Okay, we're going to do a demonstration, but the RunLink is a direct development system on a web page. So it means that the IDE is actually sitting directly on the browser. The web page actually exists inside the Wi-Fi chip, and the Wi-Fi chip is connected to the controller. So when you can access the Wi-Fi chip and the web page which is on the Wi-Fi chip, then you also have access to everything on the controller. So you can set inputs, outputs, you can then access those, and you can write code, and you can even develop your own web app directly on the Wi-Fi chip very rapidly, which we're going to demonstrate today.
Sure. Can I share my screen, Miro, with the platform?
Yes. Do you have the link?
Yes, Miro. I've taken it up. Yeah?
Okay. Actually, before you do that, I have to turn my screen around. So if you can unshare, then I'll turn the screen around so that I can share my devices.
Sure, Miro.
Okay, I can't turn around my camera unless you unshare, sorry, not on this platform.
I think there's something in the settings which you can just click and turn around.
I can do it easily. If you just unshare, I'll turn it around and you can share again.
Sure.
Thank you.
So friends, as you can see, this platform which is called as RunLink has been developed by Miro. So this particular platform, it sits within a controller. So it has been published by the controller to us. So what we're seeing right now is a page from an IoT device called as the Node MCU, on top of which Miro has built a complete embedded system to control a lot of devices. So through this software over here and this particular tool, I will be able to control devices across the world. And the best part about this particular tool is, let's say for example, you made a robot and you give it to the customer. So once the product has gone to the customer, it cannot be brought back. You cannot do anything with that. But here what happens is, through this particular tool, even after the robot has been given to the customer, you can modify the sensors, modify the parameters. You can send the code back to the robot. That is the power of this platform. So even once your product is being deployed and is live, you can still get all the modifications done by sending things across.
So if you can, sorry, just stop your share just for a couple of seconds, I'll be able to turn around my camera and we can do the demonstration.
Sure, Miro, please give it a try. If you need some help, Mr. Sukumar or our team Bharat can also just give you some small inputs.
No, all you need to do is stop your share and then I'll be able to turn around my camera and then you can start your share again.
Okay, I'll just stop sharing. You can try now.
Okay. Thank you. Now you can share again. Thank you. It's okay for you to share now. Yeah. Okay. Thank you. So this is actually the page that Uday has opened in India. This is the page that I have in Australia, and this is a copy of the page, but it is not live. The page that Uday has opened in India is actually inside this Wi-Fi chip. So inside this Wi-Fi chip, you see the red dot. He has accessed the page directly. So actually that means that, for example, he can turn on and off the blue wire, which is an output, if he sets it as an output, which will then turn on the magnetic relay, which can turn on the lamp. Okay, this lamp. So, Uday, if you can go to C4. Okay, unfortunately on this platform my video is very small. So if you go to C4, just make it digital out.
Right. Done.
Okay, and everyone can see a red button next to the C4. So
Right.
the red button is actually a signal on here, but the signal is off at the moment. So if Uday presses the red button, then you see straight away the lamp here in Australia turns on, okay, because he has activated the signal on the Wi-Fi chip here in Australia, even though he's opened the web page in India, okay. So Uday, yeah, turn it off again. On C7, we have port C7, so these are the ports. We have connected a sensor. It is a light sensor. So on C7, Uday, if you could make it a analog in, good. So people can see there's a number 207 on this sensor. This is a light sensor. So you can make the number higher if you put on more light. So if you turn on the light again, okay, everyone can see that the number actually goes up. So 236. Okay, if I now cover my hand, you see it actually goes down, okay? And if I cover it more, it goes all the way down to about 20. Okay, uncover it, goes back up. Okay, even though the controller is in Australia. So this is Internet of Things. We can check the inputs and outputs. Now what we can do though is we can actually develop on this. So if we go to C4, then type in the word lamp, L-A-M-P, lamp. Okay, so C4 will have the word lamp, and C7 we will put in the word sensor. Okay, this is on the name. So we've basically configured the ports, we've tested the ports, and now we can go directly into standard JavaScript loop to, Uday, if you go down one, we'll put it into the loop because it'll repeat. Okay, so inside the loop, what we're going to do is create an automatic code so that if we cover the sensor and let's say it goes under 100, then it will turn on the lamp. So if we type in the word if in lowercase, okay, just type in the word if, like that, round brackets, and then we can go to select macro and select analog in, select sensor. Okay, put the cursor next to the round bracket, press add macro, and you see analog in sensor, good. So now we take the cursor, we take away the semicolon at the end and simply put in less than 100, less than sign 100. Okay, you notice that this platform is very good for teaching because basically I'm going through a project with Uday from Australia and stepping him through how to do this. So under the if it's less than 100, we want to turn on the lamp. So simply select on the macro, select turn on, and then select lamp. Put the cursor under the if and press add macro, and it says turn on lamp. Type in the word else, E-L-S-E, on the next line, good. And then we select turn off lamp and we put it under the else, so it becomes 4 lines. So turn off lamp, add macro. Okay, very good. If we then go to the top and simply press run code, usually at this stage we have to send the code, maybe compile it, put it into the chip, etc., or put it into the cloud. On this platform, we don't need to do that. Simply press run code, and then we can run the code immediately. So we have here the light sensor. You can see the number. If I cover the number at the moment goes down to 194, 198, 160, 150. Okay, cover it more. Goes down. Okay. All right, so Uday, you're missing a bracket. So just press stop code. And after the word sensor in your code, there needs to be an end of bracket.
All right. No, there is, Miro.
After the word sensor, before the less than. Before the less than sign. Yeah.
Right.
That's it. Okay, so let's run the code. So you can see the testing cycle is actually very fast. So let's cover the light sensor again. Okay, this time we actually have the lamp turning on. Okay, and if I uncover my hand, turns off, the number goes back up. So it turns on if it's under 100, turns off if it's over 100. Okay, very good. What we'll do next is actually create a 2-button web app. So we'll create a web page with 2 buttons inside the HTML. In the HTML, we're going to put in a heading. So we'll type in H1, rectangle, H1. Okay, and then we'll just type in, let's say, alarm control buttons. Alarm control, maybe alarm control web page. Okay, because actually we're making a web page. Alarm control web page. End of triangle. Okay. And H1. Good, you've already done it. So just to show where it goes, go up to the top and press stop code, run code. Go down to the bottom of the page and you see that there is actually a section at the bottom of the page where it says alarm control web page. Very good. What we'll do is build two actual working buttons on the alarm control web page. You'll notice today that I'm not using any libraries, that we're directly putting in the code so that you can see that you can understand the code and it can actually be done quickly. So put in a triangle, type in the word button, standard HTML, you can actually type in button, and on click means that when you press the button, then it will do some code. Okay, so let me just show that. You actually need to have a space after button. Okay, take out the rectangle so that there's just straight button and then a space straight after the word button. Okay, and then lowercase on click equals. Okay, and then quotation mark, and we're going to type in turn on, uppercase turn on. Okay, just like that. Needs to be the right case. So just go back and lowercase turn, capital O and N all together, one word. Okay. HTML and JavaScript are actually case sensitive, so we need to make sure that everything is correct. This is a command, turn on. We'll put in the round brackets and we'll actually type in the word buzzer. Now, we haven't even allocated where the buzzer is yet, but that's okay. We can go back and do that with the system. So we'll just type in the word buzzer like that inside the brackets. Okay, then we can end the quotation and okay, end the triangle like that. And then we want some words on the top of the button. So we're going to type in alarm on. Those of you that are familiar with HTML, you know that it's actually not very much code even to make some colors, change the size of the buttons or the text. Okay, we'll just make it simple today, and then slash button. So there we have a working button. Find where that is. So alarm on is the text. Just check that. So we have button on click equals turn on with a capital O, buzzer, and then on the top we have alarm on. Let's create an off button as well. So let's copy that line, paste it underneath. Okay, and then change the turn on to turn off. So where it says turn on, we change that to turn off, and on the top, alarm off. Okay, now where is the alarm? Well, the alarm is actually the buzzer connected to C5. So if you go and configure C5 as digital out as well, and make sure you type in the correct spelling and upper lowercase that you used, then we can simply go to stop code and run code. And we'll see actually two buttons, an alarm on and an alarm off. So if you then actually press those buttons on that web page, does the alarm turn on? Okay, I'll just put my microphone next to that as well. Everyone hear that clearly? Okay, if we press off, it turns off. So it's actually loud enough to be heard from Australia to India. Okay, we'll turn it off again. Very loud over here. Okay. What we want to do now is we've actually designed a web page with two buttons. We've designed some JavaScript control. What we're going to do is we'll just press the stop code and we'll take it off of the development system and just open up the web page directly that we've created in this project. So at the top, Uday, just the address that you have, just remove or delete the /control.html and press enter and go direct. Wait, before you do that, don't do that yet. Oh, okay, all right. Okay. So, yeah, that's good. So if you press the alarm on, does it work?
We can't hear Miro. It is on, but we can't hear.
Okay.
Not audible, Miro.
Not audible? Okay. Just press it again. Okay, can't hear it. Just press the alarm off and then the alarm on. No, okay. There might have been a step we missed. So just go back a page. Control.html. Okay, so normally we actually press the board and the send. Okay, so we actually send the project, but in this case, just go down and press the get. Okay, we do have that. So okay, just press the send. We send it to the board. Okay, so we save the editor file and we save the index file. Okay, now delete the /control.html. Okay, all right, good. So now alarm on is working, and if you press the alarm off, it should turn off. Okay, good. And if I cover my hand, okay, and the sensor, you can see that it's still running the JavaScript loop. Okay, so you see that we have actually then created the web page very quickly. On other systems, in fact, to create 2 lines of code, 2 buttons on a web page, for example, on Arduino, if you look it up, our university students over here have looked it up, and there's a 20-page booklet, and after 10 hours they're still having difficulty because they need to create the web server. So the RunLink actually then is able to take care of all of their connections very quickly. Because of the rapid development, as Uday said, we have had Max actually develop this application. So this is a model, and inside the idea is that the biomatter that goes in becomes fertilizer. The methane gas is actually trapped. When the methane gas gets trapped, then it can be used for fuel, because burning methane is good for the environment. Methane is 28 times worse for the environment than carbon dioxide. Turning methane to carbon dioxide is actually a good thing. Okay, so once we have done that, then we can use that either for fuel directly to burn and cook, or we can turn it for fuel to create electricity for the farmer. So this was taken to the World Young Inventors Competition, and Max actually ended up winning the overall trophy. Okay, so this was 20 countries competing, and he actually became Best Young Inventor last year. Okay, so that means that we can rapidly develop these things, but we also have others. Did you know that on the HTML you can actually just have 1 line of code to put your camera vision, and also only a few more lines of code you can do object recognition for artificial intelligence. In fact, JavaScript runs TensorFlow AI faster than Python because it uses the graphics processor directly on your device. So we have a simple example where you can open a link which is created by RunLink, and you can point your telephone camera onto an object, and if the confidence, it will show the object name and the confidence level. If the level is above 0.5, then it will actually speak and tell you what the object is. So what I'll do is I'll put that link onto the chat, and also some online RunLink projects that people can see as well. Okay, all right. Okay, thank you very much, Uday.
So, Miro, do you want to talk about AI as well and how we can recognize objects?
Yes. Like I said, on the run link inside the HTML, you can actually put in a single line of code to create vision, and then in the JavaScript, you can then use that camera vision to capture that, and you can run the TensorFlow library directly on your device because it uses a graphics processor. Then very quickly it can identify and even speak. One of the things I did find interesting recently is that JavaScript enables text to voice within 2 lines of code, whereas in Python, I think you have to convert it to an MP4, and it really becomes a difficult process. So JavaScript is actually very good for processing AI. The second thing is that if you use the JavaScript, it means that you can then connect it directly to your web page very easily, and you can use it on mobile devices, because Python is actually quite difficult on mobile devices as well. And web pages can open on phones, they can open on tablets, and they can also open obviously on laptops, computers, MacBook, Mac, etc., even iPhones. Okay. All right. I'll send you the links on the chat for this so that people can actually see it as well. There is, in fact, even a document for the object recognition, and I'll give that out as well. Okay. Thanks,
Great.
Uday.
Thank you so much, Miro.
I'll that back to you, and I'll put those things onto the chat.
Great. So if you see, Mr. Miro has sent a lot of information for us on chat. So he's actually given us a platform to try out RunLink so that we can, as educators, we can guide our students as to what they can do. And he's making this available for us free of cost. He has joined us all the way from Australia. And on request, he has actually made this tryable for free so that we can experience the power of RunLink. Though he has taken a lot of time and effort and he's built the hardware by himself. Thank you so much, Miro, for giving us the opportunity to try this out. So all the guests here, you can use that link, which either will be getting as a mail or in the chat right now. So you can try this out by yourself, and later on can teach the same to your students. Thank you so much, Miro. That's great. Thank you for joining us. So if you have any doubts with regard to what Miro has shared with us, you can please leave in the chat. So I'm sure Miro would be happy to take a question or two if you have any questions. So Mr. Subamar will be helping you with all that, with the feedback form, the mail ID and all that. I'm sure he has all your details. But other than that, let's say you have some particular questions to ask Miro, you can please feel free. Please ask in the chat and Miro will be happy to answer you. So again, Cisco's is going to be a network tracker. It's only about how effective the communication is happening between the two devices in an IoT platform. So you wouldn't call it IoT, but the packet tracer for IoT would actually establish how good your data transfer and protocols are happening. Amir, I think this is for you. Is this a web-based control? Mira, are you there?
Yes, I'm still here. Okay, if you have any questions, then that's fine. Unfortunately, my chat is disabled, so I can't actually paste anything at the moment. But
Dr. Sukma, if you can please help Miro. He wants to share some links, which will be like access to the platform. So either always Miro can just leave it with Mr. Sukumar. Please send it across. Now, Sukumar, you can just please enable chat from here. You can also drop it in the chat box, so we'll be able to have access.
Sir Rahman, sir. Sir, please make him as a presenter or admin, sir, so that he can share the link. Rahman, sir.
Okay, I'll try it again. Thank you.
Meanwhile, you can also answer Miro. Is Runlink a web-based control?
Runlink actually works either directly across the IP, where you don't need any internet, which obviously makes it very secure because it's disconnected from the internet. It can work on the local network because the actual Runlink is inside the Wi-Fi chip. Doesn't need any other server. But you can also take that IP and you can fly it using services onto the internet to have internet access. And of course, once also, if you have got internet on the network, then the Runlink can connect to any internet services as well. So, for example, the object recognition can use TensorFlow libraries, or in fact, because it's JavaScript, it can connect to your camera, to your voice on your device. On the phone, it can even connect to the accelerometer. It can connect to the GPS. It can send email, etc. All of those services because it's connected to the JavaScript Runlink. On the HTML, of course, it can also then connect to pictures, Google services, IFT, etc. as well quite quickly and easily. We do have examples of that. I'll put that onto the chat. Hopefully I have access now.
Great. Thanks, Miro. So, and next we have one more question that says, are there any open source platforms similar to this? Okay, so first and foremost, so though Miro has put in so much effort, he is trying to make Runlink available for everyone. So the only requirement here is that, so we've developed the hardware for the same. So if the hardware is being made available to students, the platform is completely allowed for any number of tries. So the students can build on top of the platform. The platform will not be charged for. So the complete device, the architecture, the framework, the manufacturing has been done completely by Miro and his team. So it works on two different devices. First and foremost, as a base controller, we have microchip PIC based 18F series based controller. And on top of that, there's a level which is built using Node MCU, ESP8266, your Wi-Fi module. And this particular server is running within the Node MCU module. So for this to run, if not from us, from anywhere also, we need to get a hardware definitely. Without hardware, IoT cannot happen. The benefit when you work with us is that one, the Runlink platform comes with it. So the platform will not be charged for. It will be open source for all the customers also. Let's just say you want to deploy a solution in your college where, let's say, the chairman would like to control the street lights in the evening after the office hours. So this particular solution can be deployed, and we can give the chairman the link, which will be completely open source or free forever once the hardware is in place. And this complete street lights can be controlled from anywhere in the world. And also, let's just say you want a sequence saying that street lights 1, 3, 5, and 7 has to be done. In that case, we can do it. So this link Sukumar has shared. The information with regard to all these links where you can try it for free will be shared with you in your Telegram group. So Mr. Sukumar will share the same with you. You can please try them and give your feedback, and any help you need in terms of support or, let's say, product development, our team will be happy to help you. So anything else you want to add here, Miro?
I'm still not able to do that, but Uday, I have shared that information to you, and maybe you can either paste it in or share that later as well. One of them in particular is actually extremely interesting because directly on your phone you can just open the object recognition and you can try the RunLink example. But also what's more interesting is I will send the document and you can see just how short the code is to make that work. And you can modify the code yourself. I would suggest, because it's so easy to manipulate text, that even people can change the code instead of the voice just saying what the object is. Maybe it can also spell the object, and it can become a teaching tool for people as to how to spell things even when they see objects. So it's that easy to change. So I'll send that document so people can see that as well and actually see how the RunLink works directly on the object recognition.
Perfect. Thank you so much, Miro. So, Miro, what Mr. Sukumar has told us, he'll be sharing the links to them personally on Telegram group so that in this case it won't get lost. So that if it's in chat, they might miss it. So it'll be sent to them personally, all the links. So Mr. Sukumar will help us by ensuring all that happens so that all the participants get something really cool to take away. They can try out in their own colleges. Thank you so much, Miro.
Thank you so much, sir.
Okay, thank you. Thank you very much, everyone. Thank you.
Thank you.
Yeah.
Bye-bye.
And, hello from Australia and goodbye, and hopefully we'll see you again. Thanks.
Thank you, Miro.
Okay.
Thank you, sir. Thank you so much.
So next we have Mr. Francis Regan from Singapore. So he's incubated in NUS. So he's a specialist in material technology. So he manufactures 3D printers right from PLA, ceramic, and right now he's working on building India's first collaborative metallic 3D printer along with NUS Singapore. They're trying to manufacture it completely in India, making it a made in India product. So we have had the privilege of working with them on a couple of printers, and together we've also built a ventilator right now to help in the pandemic. And he also is helping us to work with institutions towards setting up 3D printing labs on campuses. So students themselves can build their own 3D models and deploy them as a product. And he's also helped many companies, including bakers, chocolate makers, dentists, and all that, to launch their own molds so they can bake, they can make, and they can even make automotive spares so that with a rapid prototyping tool like 3D printing, they can test it out before it is deployed. So over to you, Regan.
Please.
Thank you, Uday. Thank you so much. Hi, everyone. Good afternoon. My name is Francis Regan, and thank you, Uday, for a wonderful interview. It's so nice to be talking to students and educators. So, as Uday said, we are a team who are extremely oriented towards education. So, we have a strong passion for learning and teaching. So, our team is actually formed out of National University of Singapore. We are all graduated out from National University of Singapore. So there are professors, PhD holders, masters holders. So we work on various types of mechanical machines with embedded with IoT. So one of the machines which are very unique, which I have here right now with me, is this one that you can see called Acets Fdp Vit Bhimavaram. I hope you can see my screen. Okay. So this is a robotic pick and place manipulator as such. So which we converted it as a 3D printer. So we have a couple of patents on this design. So we are the only ones in the whole world who make this type of 3D printer. So this was completely implemented with the help of National University of Singapore. And we also have other types of 3D printers. You can see these are mostly for education institutions, rapid prototyping. So there are a couple of parts on the model. So you can see that they are all printed and ready to be taken out. So we manufacture 3D printers such as these, and we help students. So how IoT can help in these equipment is that say for a 3D printer, if for people who don't know what the 3D printer is, you give a design file and the 3D printer can print it out and give it to you. So you can see here on the plate. So these are all printed parts, right? The printer just printed all these items and just gave it to us. So this is what a 3D printer does. So what happens, what the major problem is, each part that you're trying to print here, it takes a long amount of time. Say, for example, 10 hours, 12 hours. and it has a lot of failure states. So with the help of IoT, we can constantly monitor what is the status of the printing right from a mobile phone by sitting in by sitting at our houses. So having dinner, so we can just check what is the status of the printing that is happening on the 3D printer. So we can get live updates, and if something is wrong, because this is electronic device, and the hot end, the printing hot end that you can see over here. So this bit, even over here for the copper, so this bit, it there's a very high possibility of the whole system getting into a fire accident. So we have to be very careful. So that is where we use IoT, and it has been very helpful for us. We have set up IoT-based 3D printers for big labs, for factories, so where they have like 100 3D printers and they let it run continuously. And it has been very, very useful and very helpful. And we are partnered with Uday for manufacturing these type of 3D printers in India. Also, we have other initiatives which is going on, as Uday had mentioned. And thank you so much. I hope I gave some useful insight to you. If you have any questions, you can ask. Thank you so much.
Thank you, Regan. Participants, if you have any questions to ask Mr. Regan, he'll be happy to help you. So he has made a lot of devices, ventilators, 3D printers, and he has a vast experience of working in Singapore, and he also has a semi-manufacturing setup in India as well. So anything right from a basic mechanical design to a complicated printer, he can do anything for you. He's also a specialist in computer technology, so he can build the applications, the layers, all that by himself also. So anything you need in terms of an end-to-end integration, right from the layers, the protocols, the hardware being used, the sensors. So Mr. Regan can give you a one-point solution. So he's here with us for another 5 minutes. If you have any questions, you can please ask him. So Regan, you have a question saying that how much does a ventilator cost?
Huh?
You've been asked how much does a ventilator cost which you made?
Oh, the ones which we made. We had two models. One was the ambu bag design. So the ambu bag design one was around 10,000 or something. And we made the ICU style ventilator also. I made the ICU style ventilator too. And actually, it's not done. It's still under work. So that one would cost around 1.5 lakhs, approximately.
Right. So basically,
I think that would be the cheapest. I think that would be the cheapest in the world.
Yeah, so basically what has happened is we've made two particular models. So one is going to be an immediate, a very low cost model, can be used by everyone, say as low as under 10 to 20,000 multiple variants. And normally let's say something like this would cost say 50,000 or 1 lakh outside if somebody has to make it. So we built a very low cost, completely homegrown variant. Another one is being in progress in partnership with a lot of hospitals. Is a version is like a lakh and a half. The right now the market price for the same thing is about 10 lakh rupees. So same thing, we're able to achieve such a cost reduction because at every stage we look for the right alternatives. And with 3D printing and IoT, the complete chain is being made very, very small and faster. So even doctors are getting updates with regard to patients' health. So what is being taken in, what is being the acceleration ratio, and all the number of threads are being counted. So which gives the doctor complete analysis about the patient. So with IoT and 3D printing, combined with embedded systems, a complete product can be developed like this.
True.
So Regan, they're asking what kind of protocols are used for precision control, if any. Can you describe the high-level modules?
Precision controls.
Protocols for precision control.
So there are a couple of protocols. So the common ones when we're talking about precision control systems, the very easiest one is just a machine code system, just a keyboard system. It's been used for ages, and it has been very reliable, very robust. So you can just use encodes and decodes for extreme accuracy and precision. If you want more real time, you'll have to get into RTOS, real time operating system. So RTOS will give some good reviews, will give some good benefits, especially when it comes to real time. Apart from that, it's very useful, but the actual solution is more expensive. So easiest time when it comes to microcontrollers, G codes and M codes is do more than enough for you. So all the CNC machine, lathe machine, robotic pick and place manipulators, everything that you see over there, there is a G code. Right? Straightforward. So even if you all the machines that we have here, everything is just some code system. Even the manipulators that we have, the pick and place manipulators that we have, we typically focus on the G system itself through RTOs. So through RTOs, RTOs is a real-time operating system where you can on the fly, the machine can manipulate, it can understand what it has to do and it will manipulate itself on the fly. So imagine a robotic car just going on the road. So the idea is it has to constantly detect observation, it has to constantly get the environmental information. And on the fly, it has to just predict what its next action should be. So it's not just one input, it has to be getting multiple inputs from multiple things. So that means there are multiple threads opening up. And once you get all the inputs, all you need to do is just give the machine command to the machine to just act accordingly to the data that you have received. So typically, standard, easy, robust, it is good. Nothing else. It is good. It is good. I hope that I answered.
So, Regan, your audio is quite muffled actually.
Oh, I see. Can you guys hear me now?
A bit better, but still a bit muffled, Regan. By chance we get some headphones or something, it would be best.
Okay.
If not, no worries.
Yeah, okay. I don't know where it is, so I don't want to mess it up. So the best option.
Yeah, this is better. This is good.
Okay,
Yeah.
so let me just turn off my video so my audio is better. Okay, so the best option for implementing mechanical solutions with robotic system is by using M4 system or G code. Typically the G code. So the G code is what we are using on all the 3D printers, and most of the machines that we use, we just follow the typical G code. The G code is nothing but on a three-dimensional platform, you're just clicking or activating on a three-dimensional platform. So it is the same concept is actually being used by agents, some agents, PLC, lead, then you can go into laser cutting, laser scanning. So everything typically they just follow the same standard, which is the G code and M standard. So they are very robust, very, very, very stable. So you just so that is what we use on 3D printers or laser cutters or CNC machines. But when you want to do a robot for real-time actuation, for real-time feedback, so you just use the G code, M code, and you just club it together with RTOS, real-time operating system. And once you club it with real-time operating system, you'll be able to get live inputs for the machine to manipulate. So, if anybody is looking to build any machine or actuation, I would really recommend them to study more into the G code system and just follow the standard. Just follow the standard and it will be as easy as possible. And it will be very reliable. You don't actually have to code everything by yourself. The more the code you do, the more error prone you're going to be when you're doing so that is what is the whole ideology or the whole concept. I hope I answered the question. So if you guys have any other questions, so please put it up.
Great. Thanks, Regan. Thanks much for the information. So, if you have any doubts, anything you would like to clarify, or anything you would like to take help from one of our international partners, be it Acets Fdp Singapore or be it Electronics Australia. Apart from this, we have partners in UK, Ireland also, and we also support setting up internationally certified labs, and we also get guest lecturers from experts from across the world over here. So we can support in end-to-end, right from a setup to product to project, anything else. We're happy to support. So coming back to our topic, so I'm sure you had a very good information session from both Mr. Regan and Mr. Miro, and it's all practical and live as to where IoT can be used in daily life, and that it is here, and we need to start moving towards it. So only if we expose students from a college level to 3D printing and IoT and AI through multiple, let's say, lab setups or let's say even workshops or whatever, if you have to, as leaders, guide them the right tools on the platform. And more importantly, how they can look at a project and how they can do it step by step and get the output. So I'll just conclude with one more slide. I think it's almost 1.5 hours and all of us have been here from morning. So it'll be a bit hard if I take too much of your time. So what I'll do, I'll just keep it simple so that you can just learn one last thing and we can conclude for the day. So first and foremost, you can look at different patterns of integration with the platform. So one would be the direct integration pattern. So WOT is your Web of Things API. So your thing is your device, might be your controller plus your sensor, maybe your processor and all that. So one particular controller or just a sensor with an inbuilt controller. For example, let's just say a smart light or let's just say something like a proximity sensor light switches on. So just an inbuilt one single device, when that thing to cloud, so your WOT API would run on the thing itself and just the status will go to the cloud. And second would be the gateway integration, in which what happens is you have a central server or a processor like a Raspberry Pi sitting, let's say, one per house. Into this Raspberry Pi, there will be a lot of node MCUs or ESPs connected across different rooms. So every room will have one ESP or Wi-Fi controller. All the lights, the fans, sensors like somebody entering, proximity sensors, temperature sensors, all and IR blasters, all that will be connected to your ESP. And then the ESP will use all this data and control all your devices. And all this status will go to your gateway, that is your Raspberry Pi, the server. And on your Raspberry Pi, your complete Web of Things API will be running, through which you can make decisions, get data, and make controls. So your Raspberry Pi will serve like a local server, have all the data, and all this will then go to the cloud so that the user can monitor and then control. The reason why this is very useful is, let's say for example, you're inside the house and the internet is not working. So if you don't have a centralized gateway and your what API running on that, you will not be able to control the devices in your own house, even if you're inside the house, unless you're connected in LAN. So this API and having a gateway ensures that this particular control can happen, and also the data can be stored on the server, the local server, and sent to the cloud at a later point of time once the internet is back. And then finally, a cloud integration pattern in which the API will be running on the cloud, and then through this, there will be a lot of things across the city. For example, a smart city will have a lot of parking slots, a lot of parking spaces across. So the sensor and the control can send data to the cloud, and on the cloud, they can process as to where it is free, and the user can be guided to go to that particular place to park their vehicle. So these are three different ways in which you can implement your own IoT solution. And please do make sure that the students are guided and do guide them step by step to take up IoT, because it is going to be a booming and upcoming field. A lot of jobs are going to be created in that particular area. So the areas would be IoT, 3D printing, AI, big data, renewable energy, and then you also have cyber security. So now that everything is going on internet, it has to be secure. So all these are key areas which the students have to be trained on in the right manner, so they can build their own projects and make their placements easy. So right now what is happening, the trend is the companies are looking at not the resumes, not their marks, they're trying to understand what project the student has built, and the questions are coming from their own core field in the project. So students who are answering are being taken, and those who don't are just being let go. Now the times are all the more critical. It's very important that we do it in a structured manner. And many colleges, as we know, since AICTE has brought in subjects that are optional in these particular things like IoT, big data, and AI and the likes, we need to start adding it in our curriculum, in our labs. And at any point, we are happy to support you in all these, because myself, I worked in industry and then I started my company. So I understand the importance between the transition that has to happen between the college to the industry. So when we give them the right support system in the college, definitely the outcome will be much, much better when they go for a job. So since all the efforts are being put in from the college side, this can be an additional initiative to support the students. So apart from this, what we should do is we should start allocating projects. So as faculty, I'm sure you'll all be working on industry projects. So what you can do is in your projects, please start involving the students also. So when they publish the papers along with you, we'll be adding a lot of value to them as well. And also if somebody is requiring, some college is looking at a dual degree program where you get a bachelor's from your university and BS or a diploma from a foreign university by having experts to train you. Even that can be done. And more importantly, what I strongly recommend is that I would recommend faculty to visit universities overseas, visit their labs, uh, try some joint venture projects, apply. Maybe there'll be some joint funding also. The labs can be set up, and please take up foreign projects with foreign collaborations. It will make a huge difference for a student's career. These can be applied and these can be driven. So Mr. Regan is also in NUS. If at all you require, we can request Regan for his help, and we can take the faculty and the students to do like even a 4-day or a 1-week program in NUS, and he'll be happy to get his mentors, the professors from NUS, to guide the students to see their labs and experience it in Singapore. The same can happen in Australia. Same can happen in UK and in Ireland. So being industry ready is the prime factor, and any help in this area, our team will be happy to help you. So Mr. Bharat has left his mail ID there. Any doubts, any support, and please get in touch, and we will guide you further there. So any other doubts with regard to this session, please leave in the chat box. Time is almost 12:40, so we can proceed to Q&A and feedback. We can close for the day. So I wouldn't like to take up too much of your time. Thank you so much. We look forward to hear your feedback on the session, and also if any doubts, please do ask us.
Sir, does DIA provide training for the faculty?
Sukumar sir, over to you.
Sir, can you hear me, sir?
Sir, Rahman sir, your voice is very low, sir.
I'm sorry, sir. Am I audible?
Sir, can you hear me, sir? Hello, sir.
Yes, sir, Rahman sir, we are getting your work, but it is still low volume.
I'm asking, sir, that whether DIA Labs provide any training for the students and faculty here in India.
Is sir asking, do we provide any training support? Is that right?
Yeah, yes, sir. Yes, sir.
Perfect.
In India,
Sir,
sir. In India.
yes, sir, in India. So we are based, though we have international presence. So we have our own operations in India as well. So South India, we are quite strong. So myself, I was born in Kurnool. I was brought up in Chennai. So South India, anywhere we can support. In fact, across the world, anywhere we can support. So predominantly what we do is, so right from a lab setup wherein you give us an empty space, we do the complete setup in terms of the equipments, the training, the processes, the manuals, and the lab experiments, the complete setup from scratch we can do for the college. And normally we sign MOUs for the college for international partnerships, which will help in AICTE and NAC accreditation. And we can also start to try to get foreign projects with foreign universities once the lab is being set up, only because for that equipment would be most critical. And thereon, we also sign MOUs for FDP, faculty development programs, on a regular basis, say once in a semester, where all the faculty from around that region can come in. And also we can sign MOUs for student workshops. And most importantly, we do something called the Tri Club, the Reformer in You, with the foundations of Stem Cell Australia, Science, Technology, Engineering, Mathematics Foundation, then from electronics. So here the students will be taught robotics through the robotics club, and they will in turn adopt government schools and orphanages, and thereon they'll be able to get the certification from Australia for volunteering. So this is like a non-profit or a social initiative in which we and the college collaborate to help the society.
Yeah, I request participants, if they have any questions to ask, please unmute yourself and ask.
So, Uday sir, just I posted one question. This is the question I asked in the YouTube link. What about the replacement of? So this is the question I asked in YouTube link. What about replacement of IoT with some wireless RF technology?
See, actually, RF device itself can come into IoT. For example, our central server Raspberry Pi is connected to internet. On the Raspberry Pi, you can give it an RF transceiver. If you connect to the Raspberry Pi, you can connect RF sensors to it itself. So it does not have to be replaced. Both can be coexisting. So we can always make a cross solution with Zigbee, with RF and IoT.
Sir, one of the participants from YouTube is asking that. So what could be the cost for setting up a lab?
Okay.
IoT lab.
So actually, we can, even if a basic lab just to cover the curriculum and stuff, we can start with as low as about 7.5 to 8 lakhs. It can be customized to your requirement. Can go even up to 85 lakhs, 90 lakhs, 1 crore also, based on what you want. So something very basic can also be done, and something very advanced also can be done. It is completely decision of the college. We can give all the options as to what will come in each module.
Uh, is it possible to have collaborative projects?
So for
Another YouTuber
collaborative
is
projects,
asking, sir.
so only if a lab is being set up, we get into project collaboration. The reason because the equipment, only then we can ensure that it's present. Otherwise, without equipment, having a collaborative project will not make sense. So if a college is partnering with us in terms of lab setup and complete execution, we will support in industry projects as well as a joint project.
Yes, sir. I think.
So I
Thank you,
think,
sir.
thank you so
Thank
much.
you so much, sir.
If any of the participants can give a feedback on the session, what was the experience?
They will click up and we will get the response and share it to you.
Thank you, Jyoti ma'am. Mr. Srinivas has shared the feedback form.
So any other doubts from participants?
Thank you, Rinju ma'am.
Sir Rahman sir, please ask once any doubt or you can close the session. Rahman sir?
Yes, sir. I think there are no more doubts. I think we can conclude the session, sir.
Sure. Thank you so much. Wishing everyone a great day ahead and have a wonderful year ahead.
Sir, thank you, sir. Uday, sir.
Welcome, sir.
Thank you, sir. Thank you so much for being the presenter for today's session. And on behalf of Vishnu Institute of Technology, I express our gratitude and thanks to you, sir. You have provided a lot of useful information, and you allowed Ms. Miro and others also into the session. You will. Thank you so much for that, sir.
Thank you, sir. Thank you very much. Thank you, Mr. Bharat. Thank you, Mr. Venkatesh. Thank you, Mr. Chandramouli. Thank you so much. Let's conclude the same. Wishing everyone all the best.
Okay sir, thank you so much Uday sir. And thank you Rahman sir, you can close the session. Thank you so much all. Have a nice day.
I wish you a nice day, sir. Bye, sir.
Thank you. Bye bye.
ಎಷ್ಟು ನೆಟ್ಟು ನೆಬಿಡಿ